Today we'll start the Mapreduce part. So in a Hadoop, right? So we discussed. So in HDFS about the storage, and coming to the Mapreduce is for processing. So here we discussed about the three ways of loading the data. So one is a local data, and one is a web data or other databases we have. So in the last session we covered the local data. So these two we'll see working with the flume and the sqoop concepts. Working with the flume and the sqoop concepts. So now we're going to start with the Mapreduce. How we'll process. So once we got data, we stored everything into HDFS. Next we got the client requirements. So now we want to process the client requirements. For example, let's see I got the 100 requirements in a Hadoop. In a Mapreduce, we got all the requirements as jobs. 100 jobs. So how to control and how to monitor all the jobs in the cluster? How will control and how will monitor? So we need a monitoring control that I want to schedule, I want to execute these jobs in the backend. Guys, can you hear my voice?
Yes, we can hear it.
Okay, good, thank you. So we got number of jobs from the client. All the jobs are handled or scheduled and monitored by about a job tracker. Job tracker is a master service. So it is only one per cluster. Job tracker is also only one per cluster, which schedule all the jobs which are submitted by the client. In 24 hours it's monitoring all the jobs, right, and it will schedule and execute the jobs. So once we got the jobs to the job tracker, now job tracker won't execute the jobs, but we don't know where is the input location. Job tracker want to execute these jobs, but we don't know where is the input location. The job tracker, right, will ask about the name node. We'll check with the name node, because the name node has all the information about your data, right? So job tracker will request to the name node about all the jobs information. Name node as a cluster is check with the cluster, pick up all the indexes and give to the job tracker. Name node, pick up all the indexes of the nodes information and give to the job tracker. Now the job tracker, so we'll start about the job processing. Yeah. So once we got the jobs and once we got the index of the nodes to the job tracker, right? So we got the jobs from the client. We got the index of the nodes information from the master node, name node to job tracker. So now job tracker want to execute the jobs. Job tracker is just controlling and monitoring and scheduling the jobs only. So job tracker will assign each job, one job and the input file location to the task tracker. Job tracker will assign each job and the input file to the task tracker. So what the task tracker will do, task tracker will take care of the job, index of the node, go to the index of the node, get the data and apply your job on the data. Apply the job on the data, you'll get the result. Storing into the HDFS. For one job, we did all the process, right? But here we have 100 jobs. 100 jobs here. So then what will happen? So job tracker will assign all the 100 jobs to the 100 task trackers and all works parallelly. Parallel processing concept here. Job tracker, it's controlling and monitoring and scheduling all of your jobs, and the task tracker will take care of the processing. End of the day, your job is processing handled by task tracker only. Okay. So you see in the last session, right? So we discussed about the HDFS. So here we discussed about the name node and number of data nodes. So coming to the Mapreduce, so here we discussed about the job tracker and number of task trackers we have. Okay. So what is the name node? It is a master node, and it is only one per cluster. What about their nodes or the slave nodes? Slaves. Yeah. Job tracker is a master service and task trackers are the slave services. Okay. If any one node crash, no worries. We have replica available, right? If any task tracker failure, no worries. Your job tracker will assign the job to the another task tracker. Your job tracker will assign the job to the another task tracker. Okay, and if see every data node will send the acknowledgement to the master node for every 3 seconds. That's called the heartbeat concept. Same way, every task tracker will send the acknowledgement to the job tracker. So this is called as a heartbeat concept here. Okay, so both are following the same architecture, right? Yes, these both are following the master slaves architecture, but these are all the physical machines to store your big data. This is all about the services to process your big data. These are all the physical machines to store the physically the data, and this is all the process running on the back end, running your jobs. Now coming to overall the picture, right, let's see where this job tracker and task trackers are placed. In every master node, in a name node, we have job tracker here, and in every data node, we have a task tracker. Like this, we have a number of task trackers. For example, let's see in the node 2, I have a sales data. The node 2 I have sales data. So now my client requirement is you want to apply some job on the sales data. First, as I'm the client, first the job will go to, guys, the first job will go to job tracker, right? Job tracker. So here we got the job. But if you want to execute the job, we don't know where is the input file location, we'll request the master to check the input file location. Name node will check the whole cluster and pick up the index of the node. So name node pick up the job and the index, name pick up the index of the data node 2, right? Because the file in node 2. So now the job tracker has a job and index of the node 2. Now right here job tracker want to assign this job to some task tracker. To which task tracker it will assign? To which task tracker it will assign? It depends upon the Physical location of the data. Yes, Pravina. Yes, there are no two. Task tracker 2 it will assign. Right. So it depends upon the physical location of the data. So my data is on the node 2. So job tracker that it will assign the job to the task tracker 2. So here we got the job and here we got index of the node 2. Next, what the task tracker will take care? Task tracker will take the index of the node 2. Will take the index of the node 2. So go to the node 2, get the data and apply your job on the data. You'll get the result. So like this it will process. If you see the whole process, right, is your masters or executing your job? No,
I
masters.
just had a question.
Yeah, Ravi, go
When you
ahead.
say the name node is 2, right? What do you exactly mean by that actually?
I mean the second step. I'm saying first step is the job will go to job tracker. Second step is
Okay.
it will go to name node, check the information.
Oh, okay. All right.
Yeah.
Thanks.
Yeah. So see the overall the process. So is your name node and job tracker executing your job? No. It just maintain the information about your data, information about your jobs. End of the day, right? Your data is on the data node 2 and the job is processing on the task tracker 2. Both are the same machine. So that's why, right, we discussed every data node work like a server, storing and processing both on the same node. So here every slave work like a server here. Okay. So coming to Mapreduce, you see here, right, job tracker is a one per cluster. Receive the job request submitted by the client, schedule and monitors Mapreduce jobs on the task tracker. Task tracker or many per cluster, execute the Mapreduce operations, read the data from data nodes. Step 1, client job will go to job tracker. Step 2, job tracker will request the master to get the information. Then due to the task tracker will take care of the processing on the data nodes. Once you got the job to job tracker will initialize job ID. Will initialize the job ID. So every job will get new ID. Then it will give you task tracker. So this is the important process, right? At the end of the day, how your task tracker is executing your job. How the task tracker is executing your job. Right? So once you got the requirement, go to the job tracker go to the name node, get the data, and the job tracker will assign to the task tracker. So how the task tracker is processing? So we have three steps here, the internal steps. One is a mapper, one is the intermediate process, one is a reducer. These three are the internal steps of the Mapreduce task tracker. In the task tracker, we have three steps here. So first, what is a mapper? Mapper job is nothing but like a split the data. What is the intermediate process? Shuffle and sort the data. What about reducer? Execution of your job. Execution of the job. So mapper is split, intermediate process for shuffling and sorting, grouping, and the job execution is handled by reducer. Job execution is handled by reducer. Okay, so now let's see one example here. For example, let's say if you take Oracle or SQL, I have a number of columns. Suppose I am taking the city as one column. I have Hyderabad, Bangalore, Chennai, Delhi, Ahmedabad, and again Hyderabad, Bangalore, Chennai. Like this, we have a number of records. I want the header byte record. How will process on the RDBMS record wise, right? Okay, header byte, okay. Bangalore, no. And I'm again header byte, okay. If you see here, we are wasting so much time to process the unnecessary records. But if you see in the Mapreduce, before applying a job in the reducer, your mapper and the intermediate process will split and will make the groups. Like it create the groups like Hyderabad one group, Bangalore one group like this. Whenever we ask reducer as I want a Hyderabad, it will go to the group, it fetch the data. So the processing is the bulk loading process here. It's a batch processing. It's very faster compared to the normal RDBMS processing. Okay, for example, let's see. I'll take here 2 records. So now I'll take 2 records. While doing practically, we'll see lakhs of records. So I'm taking 2 records like hi, hello, how are you? Second record as hi, hello, how are you? Bye. So first of all, right, Mapreduce will know only key and value pair combination. Remember, sometimes interview they'll ask the question like what is the format of Mapreduce, what is the format of mapper, what's the format of reducer. Everything is a key value format. So Mapreduce is the key value format here. But if you see here, we got only data. So this will initialize automatically as first record as 00 comma hi, hello, how are you? Second record as length of the first record. For example, let's say 17 comma hi, hello, how are you? Bye. If we have any third record, then it counts like 18, 19, 20 like this. Okay. So first this is input to the mapper. What is a mapper job? Split, right? So now I want to split by word. So you'll get as hi, hello, how are you? First record, and the second record we have, we'll get the hi, hello, how are you? Bye. So like this, it splits the data. Yeah. After splits the data in the mapper, right? We'll initialize the each word as a 1. Like we'll initialize the hi, comma 1, hello 1, how 1, r1, u1, hi 1, hello 1, how 1, r u by 1. So in the mapper we split the data, initialize as a word as a 1. So now this is output of mapper and input to the intermediate process. What is the intermediate process? Shuffling and sorting, right? If you see here, so we have a hi here and we have a hi here, hello here and hello here. Yeah. Shuffling and sorting like hi comma 1 comma 1, hello 1 1, how 1 1, r 1 1 and the u 1 1 and by comma 1. So this is output of intermediate process. Can you hear my voice, right? I don't know why some
Venkat, I got one question. Why you put by equal to only one? Others are like you comma like
yeah, but in the second record I have only one, right? So I don't have first record by, right? So it's only one time repeated.
okay, you're combining that first and second record,
Yeah,
correct,
yeah.
right?
Shuffling and sorting, we have 2 records now we are doing. First mapper, what we did, we split each word as a 1. Then while shuffling and sorting, we are shuffling the whole data, whole records. So combining as the two records, right? So high 1 1 like this, but finally we have by is only 1 second record.
If you have 10 records, and you should be keep on like writing like that.
This is an automated process actually. This is a back-end process. It will take care by is automated in the intermediate process.
Okay, okay. Mean to say you're explaining how it is getting processed
Yeah,
back end.
basically whatever we're discussing, there's everything back-end. So I'm explaining how it's running on the back-end part. So
Okay.
this is output of intermediate process, right, and input to the reducer. So guys, see till now I didn't say
20,
what's my job, right? So my job is here actually
20.
word to count. My job is a word count here. So in the reducer, we'll write the word count logic here. The logic part we'll write in the reducer. Mapper intermediate process is a common process. Reducer will change whenever you change your job logic. Now my job logic is a word count, so means we'll initialize as each word as a 1 and we'll count the number of words and we'll calculate the whole count result. So here if you see we have high 1 1, high 1 1, so you'll get the count as a high comma 2, hello comma 2, and how comma 2, r comma 2, and u comma 2, and the by comma 1. So this is output of reducer, nothing but output of my job, right? Output of the word count job, right? So like this will process. So any job in a Mapreduce, it will follow backend like this. So the first step is mapper. So mapper job is split the data, and intermediate process is shuffling and sorting. This is a automated process handled in the backend. What about reducer? Executing of your job. So in the task tracker, we have mapper and reducer, right? Intermediate process is a backend process. So I'm taking the 1 GB file, one job, and the 1 GB file, for example. When you submit this to the job tracker will submit to task tracker, right? Task tracker will check about your job and data. It will assign n number of mappers and number of reducers to execute. If suppose I am taking 1 GB, for example, okay, we'll take one mapper. What is a mapper job? Mapper job is split of 1 GB data and have one job, right? So we'll take one reducer. Why? Because only one job, one reducer will execute one job. If suppose I am taking 100 jobs, 100 GB file, how many mappers are required, how many reducers are required? So mappers, how many required, reducers how many required? It depends upon the file size, depends upon the jobs, number of jobs. Mappers is always depends on the input files. Reducers is always depends upon the jobs. So what I am saying is, in a task tracker, we have n number of mappers and registers available. Depend upon your job, it will take it. Depend upon your input file, it will take the mappers. For example, maybe it will take the, some 200 mappers, right? Or 100 jobs, right? 100, so 100 reducers. One job will go to one reducer. One job will go to one reducer, right? And based on the file number of files and their sizes, will take care of the mapper part. Okay. So every data node, every task tracker, we have number of nodes available and registers available, that will check in the portal. Is the portal number of Mapreduce is right 50030. So guys, we discussed the last class about the HDFS portal. What is the port number? 50070. MapReduce port number is 50030. This is standard portals. So if you use any flavor, Cloudera, Hortonworks, Map, or any flavor, these portals will not change. Okay. So here we have, for example, let's see this. I have a node 1. I have a till node n, all my input files. For example, let's see, I am taking the data node 1, data node 2, data node 3. Here I have employee data. Here I have department data. Here I have a job. My job is join. My job is join here. So I have a node 1, node 2, node 3. Yeah. Okay. Node 1 we have employee data, department data, and the join job. Now I want to execute this job. To execute this job, actually what we'll do, we'll take two input files and we'll do all the processing in node 3. But if you do like this, right, what will happen? Button to everything node 3, right? So what I am saying is, every data node, we have own task tracker. Here we have task tracker 1. So here we have task tracker 2. In a node 3 we have a task tracker 3. Depends upon your physical location of the data. That own task tracker will take care of the mapper task. Mapper 1 output. Mapper 2 output will get here. In node 3, in a task tracker we have a reducer, right? This reducer will take the job, will take these two mappers outputs and then start the processing part here. If you see in node 1, how many mappers we used? One mapper, 0 reducer, right? Node 2, one mapper, 0 reducer. Node 3, 0 mappers, 1 reducer. For total job, how many we use? Total we use 2 mappers and 1 reducer. Why 2 mappers? Because 2 input files. 2 input files we have. And we have single job, one job, right? So 1 reducer. If you see this screenshot, because my job is on node 3, so we are taking reducer on node 3. For example, let's see, I have a node 1 to node n, all my input files. All will take care of mapper tasks. In node x, I have a job. So these all will shuffle and sort here. We'll go to reducer, we'll execute here the process. So in the back end, it will run like this. So we see now, there will be possibility one data node. No, yeah, we can take number of reducers in the task tracker. It depends upon how many jobs you're submitting. Right now I submit my one job. Okay, so if you submit the more jobs, it will take the more reducers. I'll show you all the ways of scenarios practically. This is all the backend theory part. Okay, so let's see here. Map phase, mapper tasks are run parallelly, right? So, and number of reducers we have and number of mappers. Locality, job tracker divide the tasks depends upon location of the data. So we discussed job will go to task tracker 2. Why? Because the file is in datanode 2. So job tracker divide your job depend upon the physical location of the data. And see, try to schedule the map task on the same machine that has physical data. Just now we discussed mapper task will take care by the input node task tracker. Parallelism, number of mappers works parallelly, right? And number of reducer works parallelly depend upon your jobs. Fault tolerance, if any task tracker failure, no worries, job tracker will assign the job to the another task tracker. Okay, like this we have these important points here. Okay, let's see. I'll show you the how the portal of Mapreduce about job tracker, task trackers, how many we have in a task tracker, how many we have a mappers and reducers. That all the information you can see in the portal. Okay, it takes some time to start. Okay, so whatever we discussed, guys, everything is a back-end part. Everything is a back-end part. Then how will apply your job to front end? Every time you're talking about job. So who will submit the job? We will submit the job manually to the Mapreduce. Once you submit the job to Mapreduce, then they have a backend mechanism that follow the process as job tracker, task tracker, mapper, all the step by step. But how you submit the job from front end? That's the important part. So, for example, let's go with the Java. In a Java, we will write the coding part of mapper class, how you want to split the data. You write a user class, how you want to execute your job. We will write the main class. We'll configure everything in this class. Like this we'll do in Java. So in a Hadoop, we have a Mapreduce. So now the step one here is we need to connect Java to Mapreduce connectivity. Java to Mapreduce connectivity. So here what we'll do is we'll do the build path. Build path means we'll connect to Java to the Mapreduce. In a Mapreduce, we have some default core jars are available. Core jars. So need to add the jars into Java. Then we'll get the connectivity. So this is called build path. We need to add that Mapreduce jars to Java. Then we'll get the connectivity. Once you got the connectivity, but still Mapreduce don't know about your .java classes. So right, it will export all the 3 Java classes into single runnable jar file. Into single runnable jar file. All the 3 Java classes into single runnable jar file. And that jar file will execute into the Hadoop system. See guys, this is all the manual process. Writing the coding part is a manual, compilation manual, and execution optimization part is a manual here. Once you submit your jar file, Yeah, we need to add all the packages. Yes, all the packages in 3 Java classes only, and we need to add the jars into the Java project. Then we'll create a one single runnable jar. Means it contains everything. So this jar file, this is the final jar file. So until this, everything is a manual. Coding part, compilation, everything is a manual. Once we got the jar file and input file location, we'll submit to the Mapreduce. Nothing but job tracker, right? So now here start the execution process automatically. Start the execution process here backend automatically. Means first the job means nothing but jar, right? Jar and index of the node to the job tracker. Job tracker will assign the job to the one ID and go to the task tracker. So job tracker will check the input file is correct or not. If the input file is wrong, that will throw the error as file does not exist. Then it will go to the task tracker. Task tracker will extract the jar. What is in the jar, guys? What is in the jar? This jar contains, we have a mapper, reducer, main class, right? So in the task tracker, what is the first step? Actually the backend mapper. So this mapper will execute, depends upon your mapper logic. Depends upon the mapper logic, it will execute. And the result of the mapper will go to reducer. This will execute, depend upon reducer logic. And the result storing into the HDFS. So here when you're submitting a job, we'll give you the output location also. So the storing into HDFS to the output location result. See so much processing, right? That's why we discussed, if you go with the Java, a small requirement also take 3 to 4 hours time. Writing the coding part manually, compilation manually, right? It's all manual part we have. But the same job you can do in a Hive max half an hour time. So see, through Java we are doing all this manual process here. Coming to Hive is a SQL language. It's a warehouse. They have their own language. It's called Hive query language. It's same like SQL. Here, right, we'll just submit the query. Just submit, write the query and submit. Then backend we have a driver. So this driver will take care of the automated process, automatically compilation, optimization, execution. Everything is automated. And backend is hitting to the Mapreduce processing. You'll get the result here. So the job of through Hive also is going to Mapreduce, but everything is done by automatically backend driver. The same job you can do in a pig 15 minutes time maximum, because the coding part is a very less compared to Hive. In a pig, write the scripting language. That coding will go to the Mapreduce processing in Hadoop system. Here also it is a automated process. Okay.
Venkat, I got one question.
Yeah.
You're doing the same Java Hive Pig, right? Like, who is a decision factor? You have to do it in which Java or Hive or Pig? Everything you will have in the office, right? Like when you go to like any organization, everything will be there, right? It is like our decision making, or they will tell us.
So actually, whenever we got the business stories, like user stories, the requirements, nothing but, right? We analyze the stories and we'll do the POCs. We'll do the POC through Hive, through Java, and through Pig, and we'll finalize one. The best way is go for Hive. Okay, the best way is go for Pig. The decision will take care by like the data scientists, or we'll say final report. Okay, so I'm using a hive is very best, I'm using a pig is very best, and we'll start the project through one process. Nowadays all the requirements are we are going with the hive. Why? Because see, you know every client, they have their own database. The problem is they are unable to handle, they want to migrate. So if you are migrating the other databases to Hadoop, what will you use?
Java.
Sqoop. Use a sqoop, importing into the Hadoop, right? Yeah. If importing into the Hadoop means nothing but HDFS, right? But I want the whole database into the Hadoop database. Nothing but Hive. Hive is a warehouse. It contains all databases and tables. So here advantage is I can directly import other database data into the Hive directly. Automatically also. Automatically means I will not create any table structure. Sqoop will create the table structure with the data. Here what the advantage is? You just write single query. That query, it imports all the tables of your database to Hive database. Right? If suppose if you go with the Java or a pig, then what you do is importing into the HDFS and HDFS to Java or HDFS to pig, you need to do manually. So this is a long process. Instead of this, now every project we are dumping directly to the using a sqoop to the Hive. Then Hive you are doing storing and processing and retrieval, and finally we'll make the reports. We are doing analytics here. This is what. So that's why Hive is the first priority. In a Hive, okay, we are doing storing, processing, analytics. In some scenarios, if you are unable to analyze the data using some default functions, we have a UDFs concept, user defined functions concept, that will create our own customized functions. In this scenario, we'll use Java. But if you're a Hive developer, there must be a Java team support available in the team. They will always take care of any backend changes on the flavor wise. They can help you for this part. So what I'm saying is what I'm saying is Java is not a mandatory, but if you know, okay. If you don't know, right, you need to get the grip on Hive, pig, and some advanced components, right? That will help you. Okay. So we'll see all the ways. So we'll see that all the ways. Okay, Java and Hive and a pig, but you need to practice more grip on the Hive. It's very important topic.
Hi, Venkat.
Yeah.
Do we need to learn that MongoDB or Cassandra?
No, not required. See, we are here, if you see in the course, right, we covering the HBase. HBase is a NoSQL language. What is the Cassandra? NoSQL language, right?
Yeah.
Cassandra, they used till last year some outside tools like Cassandra for NoSQL, but now we got HBase in Hadoop. They're doing the same job. So we're using HBase. I will cover the HBase also here. So that's like NoSQL language only.
Okay, but it doesn't matter. I mean, some clients may use different one, right?
If the client asks Cassandra, they say you worked in HBase. That's fine, because both are doing same job.
Okay.
The problem is in the market, right? If they want something, or they'll ask everything.
Yeah.
Right?
Yeah, I can say that they're asking Hortonworks. See, you're telling all flavors, right, Cassandra, like Hortonworks, but they are asking everything. How one person can be worked in everything, right?
Yeah, I understand, but this only thing is if you use any flavor, that is same. Hortonworks mapper. This Hadoop is Hadoop, right? The way of opening and supporting is different based on the flavors. But no
Okay, so
worries.
you mean,
Once you got the grip right, then you can answer all the questions. I can give you that confidence by end of the course. So the only thing is just get to go ahead with the practice on everyday basis. And coming to the flavors like Cloudera, Hortonworks, Mapper, everything is the same. So in real time we'll use through putty, we'll count it. So I'll show you the multi-node installation with the manual installation part with multi-node. That will you get the administration part also. So that's not a problem. Okay, so right, we'll start the Java on tomorrow session. We'll see the practical. So here the important part is how we are executing the Java jobs into the Hadoop. That is a very important part. Okay. Ishwari, can you please ask your organizer? Okay. Okay, guys. Fine. So tomorrow we'll start the practical